Dan Tyrrell. I'm an assistant professor at the University of Alabama, Birmingham. I'm here with Sonali Gnanenthiran, who's the Karl Link Award winner in thrombosis. And can you tell us where you're from? And I guess I'd want to know a little bit about how you conceived of this project in platelets, PAR 1 and 4, and the elderly.
So I am from Sydney, Australia. I'm a cardiologist. I work at Concord Repatriation Hospital in Australia, and I also work for the George Institute for Global Health. So this project really, for me, was almost a love child because no one else wanted to do the project. But I wanted to do, because I saw a gap in sort of aging research and cardiovascular disease, and most cardiologists are not very excited about the area, but I was. So I had to really fight to get someone to help support me do this research, and I think it's very, very important.
Yeah, I agree. I also study aging, so I understand the importance of aging. Can you tell us a little bit about why nobody else wanted to do the project?
I think they thought it was boring, but we clearly know that it's not. But I think that's really the issue, that it wasn't seen as a sexy interventional topic. It's quite this particular it's a basic science topic.
Yeah.
But it's very important, I think, for us to understand what normal aging processes are with age, for us to understand cardiovascular disease in older people.
Yeah, so kind of building on that, you're kind of in the middle of basic science using mouse models and then translation into the clinic. So I guess going backwards, are there any plans to translate some of these things into clinical practice?
So we hope so. So my current the study that won the Karl Link Award is it is a human study. So it's a study of 170 community dwelling people. We had 3 age groups: a young population that was 20 to 30, middle-aged of 40 to 55, and an older group that was more than 70 years old. We looked at the basic platelet characterizations across ages. So we found a distinct platelet phenotype, which I'll tell you about later. But yes, certainly the results of what we found, we will want to try to use it as targets for future therapeutics.
Yeah, it's really interesting. So as far as publishing the work, did you have anything that reviewers suggested that were really helpful comments that kind of made the work get over the next level?
I think the great thing with the ATVB journal is that you have very experienced reviewers who give you very good feedback. So they asked us to develop certain areas, do a couple more experiments. So they certainly take a lot of work. These are not small suggestions, but they really enhanced the paper.
Yeah.
So the work now, for me, is probably one of the pieces of work of all my research career that I'm most proud of.
Oh, that's good to hear. Can you tell us a little bit behind the scenes of what was something, I guess maybe the most difficult thing or hard thing to accomplish with the study?
I think probably from just starting from the very scratch. So I'm a clinician, so I'm a cardiologist. And for me to go back in my PhD to do laboratory work, that was a really big process, because I had to upskill on those basic science skill sets that I hadn't done since early years of university, and I'm not sure that they even taught us how to do that right at the time. So I had to learn how to pipette, titrate, just the very, very basics before I could start doing this. And then this project, really, they wanted me to be very independent. And so, I was doing, I came up with the idea, I had to do the ethics. So I did the patient recruitment, I did the proposal development, and then I did all the laboratory analysis myself, including the experiments and the data analysis and then the paper write-up. So it really was, it was this incredible body of work that took a lot of work. But I think I'm really glad that we were able to publish it in such a good journal like ATV, so people can see what the results are.
Yeah, it's really, the paper is really interesting. So can you tell us a little bit about PAR 1 and 4 and what was known before you started this work?
So there was actually not a great deal known about humans and platelet activation. There was data more in ADP that was known. So we knew that in older people, their pathways, they had increased platelet aggregation to ADP and collagen, but it had not been assessed in humans for thrombin activation. So there had been studies in mice, but thrombin pathways are very different in mice compared to humans. So in humans, we have both PAR1 and PAR4 receptors that mediate thrombin activation, but largely it's by PAR1 pathways, whereas in mice it's mainly PAR4. And there's also a lack of this GP1B beta alpha sort of cofactoring mechanism that helps orientate PAR1 to thrombin that helps produce thrombin activation in mice. So they are different. So mice and human studies are not completely comparable.
Yeah, that's interesting. And so if you did a similar study in old mice and compared to young mice with similar kind of age groups, do you think you would see something similar or not?
What was interesting is in the thrombin studies in old mice, we see the reverse response to what was seen in humans. So we see upregulation of those pathways, hyperreactivity to thrombin with aging.
Yeah,
Whereas in older humans, what we showed in my study was the reverse response, which was thrombin resistance with age. And there were a number of mechanisms that we looked at. So one was this lack of, it was the GP1B alpha cofactoring mechanism. So GP1B alpha is a co-receptor that orientates thrombin towards the PAR receptors. So that was so what we found that there was less GP1B alpha receptors in older humans. So that would diminish that orientation and the thrombin activation. And then we also showed that there was less ADP secondary stimulation release post thrombin activation. And we also think there's a form of desensitization happening in the platelets of older humans in terms of the thrombin pathways, probably because of inflammation.
Yeah. And so thinking about that with aging and people, I know the oldest group that you had in the study they were about 80 years old on
Yes.
average. So if you think about the centenarians, who are kind of these super agers or outliers in some respects, what do you think would happen if you could include a group of centenarians, or do you think you could predict from some of the earlier age groups who may go on to become centenarians?
I think inflammation is a really big topic at the moment that is very much seen in platelet activation pathways. So I wonder if if you have less inflammation at a younger age, whether you're more likely to go on to become a centenarian. But it'd be really interesting to compare the platelets of people in their 70s and 80s to the centenarians. There is some limited data which actually shows that their platelets are actually probably better. They're less hyperreactivity. They have less oxidative stress. So they're this very special population. But we don't have a great deal of access to these people. But I wish we did.
Yeah, it would be interesting if you could do a longitudinal study and just stratify the lowest group, not by age but by function, and then see if they follow them out however many years. But
I think it'd be really interesting. But the nature of studies like this is that they're very labor intensive.
Yeah.
For me, just one patient would take a whole day.
Yeah.
Of just doing the experiment. So they are each and that's the beauty of all of these basic science papers, is that the numbers that you see, even though they seem much smaller compared to the large clinical trials of thousands and thousands of people, the effort involved is huge.
Yeah. And I think for my last question, because you do work in the clinic and you're doing research, so has the research you've done here informed on your clinical practice?
I think it's probably made me think more about how we can target the pathways identified. So what we showed is that there were three things that we showed in the platelet phenotype of older people. One was that there's increased basal reactivity, so more hyperreactive resting platelets, which correlated with increasing inflammation. ADP pathways were hyperreactive in older people, but thrombin pathways were downregulated in older populations. So what it, the therapeutic implications, we need to think about what this means. And one of our hypotheses is targeting systemic inflammation and thrombin generation. Would that help reverse this platelet, phenotype and the prothrombotic risk that we see in older people? But also, I think the other, the implication of the results that we have is that we've shown that, that thrombosis is different in older people compared to younger people. Like there is this profound inflammatory, inflammation plays a very key pathway in all of this.
Yeah, that's really interesting. Well, thank you for your time and congratulations again.
Thank you very much.